When we left off, the last thing we talked about was in order for a series to converge, the terms have to shrink to zero, and they have to shrink to zero quickly. I want to focus in on this bit right here about they have to shrink to zero. If you take the contrapositive of this statement, if the terms don't shrink to zero, that means that the series will not converge. And that's the idea behind the test for divergence. The test for divergence says if the terms don't shrink to zero, that's what this limit says, then the series will diverge. And so a quick note here. The test for divergence never says that a series will converge. It only says that the series diverges. So the way you use it is this. To use the test for divergence, take the limit as n goes to infinity of a sub n if the answer is not zero, then it diverges. If the answer is zero, it's inconclusive. It never tells you that something converges. So on this first part of example 4, to determine, well, let's look at the test for divergence on each of these pieces, each of these 4 series here. On this first one here, we take the limit of the thing, of the terms, and we get this. Now the limit as n goes to infinity of this is going to be 2 over 3. So that tells us that the series diverges. And if you keep in mind what that means, it means if you start adding these terms up, you plug in 1 to get the first term, 2 to get the second term, and so on. Eventually, what you get when you evaluate this is going to essentially be 2/3. And so it's like you'd add up a bunch of numbers, and eventually you're adding on 2/3 every time. Adding 2/3 every time is going to make it grow to infinity. All right, let's look at the next one. For this one, let's see, I'm going to make this a little bigger. I take the limit as n goes to infinity of 1 plus 1 over 2 to the n. Now, if you look at this, the 1 stays the same. When n goes to infinity, though, a half raised to the n gives you 0. So this gives you 1. So that tells us that the series diverges. Just a quick note here. The terms of the series converge to 1, but the sum of the series diverges to infinity. All right, let's look at this next one. This one, we take the limit as n goes to infinity of 1 over n squared. Well, this one we can do immediately. The bottom grows huge, so you get 1 over infinity, which is 0. Now this is inconclusive. In other words, the test for divergence fails. Now it turns out this series does converge, but we don't know that because of the test for divergence. We'll see why later, but this thing, the test for divergence fails here. Test for divergence is going to fail on this one too. Because when n grows large, the bottom grows large and this goes to 0. So again, the test for divergence fails.